Hello and welcome to video 1.5 of module 1. The reason this is video 1.5 is because I wanted to do a couple more examples of statistics and parameters after the previous video. So this is sort of between videos 1 and 2. Alright, so we're going to start out with a little note. Two important values in statistics that we're going to be looking at a lot throughout the semester are the mean and the standard deviation. Now, you may have heard these words before, maybe not. It's okay. You can think of the mean as like an average. In fact, when you think of what an average is, you're probably thinking about the mean. And the standard deviation is a tool that we use to measure how spread out a data set is. So just to give you an idea of what these words mean, we're going to look at an example. So for instance, maybe I gave a test and the average on the test was an 80. So we would say the mean of the test is an 80. Now, suppose the standard deviation in this example is 5. Just to get an idea of what that might mean, that would mean the values in the data set probably ranged from like a 70 to maybe like a 90. So if I gave a test and the average is 80 and the standard deviation is 5, that means most people got between a 70 and a 90 on the test. So this is a pretty close distribution. For another example, if I gave a test and the average still was an 80, but this time the standard deviation was bigger, the standard deviation is 10, then that would mean most students probably would have scored between, say, a 60 and 100. So if we have a bigger standard deviation, then the distribution has a wider spread to it. So I'm not going to ask you anything like that right now, and we're going to dig into these values in more detail in the future. So right now, this is just to kind of give you a picture of what these things mean when we talk about them. So think of the mean like the average and the standard deviation to tell you how far things are and how far apart things are. And when we look at these measures in the future, we're going to be looking at the formulas, and one of the downsides is that the formula will be different for standard deviation if we're looking at a sample or for a population. So the reason I'm bringing this up now is because when we talk about statistics and parameters, that's going to be really important because it's going to tell us which formula do we use. So there are different formulas for a sample standard deviation than there is for a population standard deviation. Because they're different formulas, different symbols are also used. So let's take a look at what symbols we're going to use for sample mean and sample standard deviation versus population mean and population standard deviation. So when we're working with a sample, the notation looks like normal letters. When we have a sample mean, it's going to be a little bit different from normal, but the symbol for a sample mean is an X with a line over it. We're going to call this X bar. So X bar is the sample mean. For a sample standard deviation, we're going to use a lowercase s. So this is not too bad to remember, S for standard deviation, X bar for mean. For the population, instead of using our normal letters, we're going to go with some Greek letters. So we're going to see what those symbols are. We're going to talk about how to pronounce them, make sure we know how to say these symbols. So the symbol for a population mean is going to look like kind of like a U with a long tail on the left, or some people think it looks kind of like an M, where the middle part of the M is like squished into the sides. So this symbol is called mu, like think about a cat, mew. That's our population mean. And the population standard deviation symbol looks like, I don't know, it kind of looks like an upside down baseball cap to me. This is sigma. This is a lowercase sigma. We're going to see uppercase sigma in the future. So lowercase sigma is the standard deviation. So if it helps you to write out the names and pronunciations of these items, the X with the line over it is pronounced X bar. I don't think we need to write pronunciation for S, I hope not. For the population mean, this is mu, MU is how it's spelled. And for the standard deviation, this is sigma, so lowercase sigma. So sample, normal letters, Population, we're going Greek. I also recommend you learn the actual names of these symbols instead of like the funny looking O thing or the U-ish looking letter. I think it was Hermione Granger who said fear of the thing or fear of a name is fear of the thing itself, right? We don't want to be afraid of these. It's the alphabet, guys. It's the Greek alphabet. We can learn it. So mu is the population mean and sigma is the standard deviation for the population. So let's do a couple of examples where we practice figuring out whether the information is for a population or a sample, meaning whether the data we've been provided is a statistic or a parameter. And then we're going to look at whether we should be using x bar or mu, or s or sigma. In the first example, an orthodontist learns that a sample of 100 adults wear braces for a mean of 32 months. So to figure out whether this is a parameter or a statistic, we need to ask, are we looking at a population or a sample? Since it says there's a sample of 100 adults, this is a sample, so that means we're going with statistic. Because this is a statistic, that means we have a sample mean of 32 months. Because it's a sample mean, that means we're going to use the x with a line over it. So we're going to use x bar to represent the 32 months. Let's look at another example. So here we have example B. Steve conducts a study on red kangaroos. He studies 100,000 red kangaroos from Western Australia, which is roughly 16% of the total population for that region. And he finds that they have a mean height of 1.5 meters tall when they're standing upright. So take a moment, try this one on your own, and see if you can identify whether this is a parameter and a statistic, and then what symbol you should be using. You can pause the video here if you need to as well. Okay, hopefully you figured out the solution to this example. So let's see, it says that Steve studies 100,000 red kangaroos, which is about 16% of the total population. So this means Steve doesn't look at the whole population, he looks at a small group of it, 16% of it. So that means he's looking at a sample. Since this is a sample, Steve is reporting a statistic. Since it's also a sample mean, that means we're going to be using the x bar to represent this value. So x bar is 1.5 meters. All right, let's do one more example and we'll throw standard deviation into it too. In example C, the mean sales price per unit for a certain product sold in the US is $2.50 with a standard deviation of 25 cents. In this example, it doesn't tell us that they were looking at a sample of objects. It just says this is the mean, the average sales price in the US for this particular product. So since we're looking at the mean across the US, that's a population. So this value, or these values, are parameters. The 2.50, the $2.50 is the mean sales price. So because it's for a population, because it's a parameter, because it's a population, that means we have to go Greek. So we're going to use the little mu thing. So we're going to use mu for 250. And then the standard deviation is 25 cents. Again, because this is a parameter, it's for a population, we're going to use the Greek letter to represent the standard deviation. And the Greek letter is this O looking thing. This is sigma. So sigma is 25 cents and mu is $2.50. All right, that concludes this little addendum to the first video. And we'll learn more about classifying data in the second video. Thanks for watching and have a wonderful day.